my talk is on Dutch books and bad explanations. So in Bayesianism, rationality is characterized by the probabilities of your true beliefs increasing over time and those of your false beliefs decreasing. Now, arguably, it's not obvious what the phrase probability of your beliefs exactly corresponds to in reality. So a popular alternative to Bayesian epistemology is what we might call rationalist epistemology. Much the same, but where your probabilities are replaced by which bets you'd be willing to accept. So being more rational means your bets tend to make more money, or more Bayes points, or whatever you play for. Then you can actually, if you want, work backwards to find out what the probabilities must have been, or to define what they are, by saying, for example, your credence for an event is 1/3, if you would accept that's not happening with odds any better than 3-1. So that definition of probability is agent dependent. It's not a property of events, it's a property of events and agents jointly, right? So some go further and define the actual probability of an event as the credence that rational agents assign to it. It's like an operational definition of probability. So what is a rational agent? Well, so far we're at risk of circularity. However, we can use the notion of a Dutch book. So a Dutch book is an argument against a given betting strategy that argues it commits you to losing points with certainty if you're offered a certain sequence of bets. So for example, if your credence of event A happening is 75%, and your credence of either event A or B happening is 25%, right? And I could say, I'll give you $1 if A happens, but you give me $1 if A or B happens. And you go, great, awesome, because that's a good bet for you, and you never make any money because whenever you win $1, you always get it back, and sometimes you just lose $1, right? You've been had by a Dutch book. Similarly, when you receive new information and your credences update by anything other than the Bayes rule, you're vulnerable to a Dutch book. So real probabilities, some say, are the personal credences of those agents which are consistent, but not vulnerable to a Dutch book. This interpretation of objective probability has some interesting quirks in specific situations. So, for example, the probability of drawing a card from a deck is defined only if all the agents are unable to access the fine details of the situation. Look inside the deck, right? Because if they can, it's no longer probabilistic, they can just tell what's going to happen. Same goes for flipping a coin, the stock market, the pseudo-random number generators used by your computer when you're playing a video game, the so-called true random numbers you can get from random.org, which is basically where they like flip a coin in a box and then have sufficiently good security that nobody else looked inside the box, so it's sufficiently well defended and therefore true. Right? And every other kind of random number generator that isn't simply nature inserting numbers into the physical world, like some fundamental stochastic process where these numbers just appear. It's heads, it's tails, or whatever, right? So, like in an attempt to push the boundary of this further, it gets particularly interesting with agents that don't know who or where they are. For example, if you take an agent that sometimes wakes up in the middle of the night, can't remember what day it is, and furthermore they live in a cave without any particular schedule to their week, then they should have a credence of 1/7 that it's Monday. And there we go, right? Because if they don't, and they accept bets from somebody trying to win Bayes points off them, they'll lose Bayes points. A second example of this kind of self-locating uncertainty is many worlds quantum theory. So in quantum theory, where doing an experiment in the lab causes the lab and the scientist to split in two, and even more than that, all the sort of thermal motions of any particles constantly cause this splitting, right? And then in Everettian quantum theory, in many worlds quantum theory, the only way to communicate between these different branches that get created is basically by reversing the motion of every particle in the room, which is essentially impossible. So agents really do seem to split in two, I don't have to assume anything about the agent, like they have a particular sleep schedule or whatever. Just like any agent splits in two, doesn't necessarily know which branch they're in and can make bets about which world they ended up in, right? So describing this again using language of quantum theory, for any two states of the world can also be in a superposition state. So the world could be in state A or state B, and quantum theory tells you it can also be in x times A plus y times B, where x and y are called amplitudes, and amplitudes are allowed to be complex numbers as well. So straightforwardly, this Schrödinger equation of physics just tells you take a particle in a state of x times spin up plus y times spin down and pass it through a spin measuring device. The world moves to a state of x times the measuring device observing spin up plus y times the measuring device observing spin down. Lily, can you grab me some water? Is that right? And after some consternation at the beginning of the 20th century with this, mainstream quantum theory throughout the entire 20th century agreed that we should add an additional rule of evolution along with the Schrödinger equation. So this rule says that at some point between the measurement starting and you observing the result, the worlds must have collapsed with chance x squared of spin up and y squared of spin down, or of their complex numbers, mod x squared and mod y squared. So many worlds quantum theory simply tries to remove this hack. So you split into two different copies when you do this measurement. And if I just ignore the thermal splitting for now, which just makes tons of copies, if you're just measuring the particle, there's this puzzle of where the hell do the probabilities come from? Because if there are two of you in the end, just like it's 1/7 chance to be Monday, you'd think, well, there's two of me, so I'm one of them. So it's 1/2 chance that it turns out down and 1/2 chance that it turns out spin up. So how is that possible? So David Deutsch will tell you that's because there aren't really two copies, there are indefinitely many copies in disguise. I completely disagree with that. But what David did do is to prove the mod amplitude squared rule in many worlds quantum theory, and the proof usually goes like this. So if you assume, it's usually described like this. If you assume that rational agents obey certain axioms, for example, that if they prefer A to B and B to C, then they also prefer A to C. So they have that preference ordering, and then if you also assume what's called diachronic consistency, so you assume if an agent wants to perform A followed by B, and then they do A, and they don't learn anything, then they do still continue to want to prefer to do B. It's another constraint, another axiom. Also that their preferences are continuous, so if they prefer world X to world Y, we assume that small variations of X and Y, like sufficiently small a world close to X and a world sufficiently close to Y, they still prefer that X prime to Y prime. And a bunch of axioms like this, then you can do a bunch of math, as David showed us, and drive that if betting agents are not vulnerable to a Dutch book, then the bets that they accept must imply that probabilities match the rule of mod amplitude squared in quantum mechanics. So from our earlier discussion, you should hopefully now be able to see that one of the popular historical criticisms of this derivation, namely that the derivation of the mod amplitude squared rule in quantum mechanics depends on a bunch of axioms, and I can just choose not to accept them. This criticism doesn't really work if you understand them not as axioms, but as just Dutch books. So, as long as the agent is internally consistent and it wants to accept bets or just with certainty isn't just like losing points, then that agent has to have, you would derive its credences as being the mod amplitude squared rule. So, the Schrödinger evolution for the evolution of particles in quantum mechanics is held up in every experiment to date, and no physical detail on this collapse idea has ever been discovered, so we haven't seen hints of it in certain situations. The idea is just that it happens at some point between experiment and seeing the result, but we don't know where. So, many worlds quantum theory is in good shape if we can make it philosophically make sense. And so what this example sort of really teaches us is that probability isn't fundamental in the world. Finally, I would also like to compare these Dutch book arguments to the meaning of a bad explanation, fairly briefly, because I'm running out of time. So for this, I will reference one of my favorite philosophy papers by the Deutsch named The Logic of Experimental Tests. Hands up if you've read this, maybe? Chris. Cool people. So I first learned about this paper as a physics student at Oxford, and I was attending philosophy of physics seminars in Oxford when it was released, and it really caused quite a stir. And it was through my enthusiasm for it that I first met David, and been friends and collaborators ever since. And the paper targets the claim that many worlds theory is untestable. And it does this by exploring what testability really means. And to do that, the paper takes a detour to explain Popperian epistemology. And one point discussed is the difference between a bad explanation and a false one. So rather than a justificatory model of how explanations get rejected, which is what happens in sort of basically every other theory of epistemology, than critical rationalism or Popperian epistemology. The paper argues that explanations are rejected by defects, by being bad explanations. For example, you could reject them in the following ways. The paper says, for example, if the explanation seems not to account for what it's trying to explain, or it seems to conflict with other explanations that are otherwise good, or if they could easily be adapted to account for anything, so they explain nothing, and to which I would add, for example, that it might explain too much. An example of that would be thinking like our future AI descendants are not going to share our human values of today because the chance of them happening to land in that corner of mind space is vanishingly small. That argument proves too much because it would also seem to, at least as stated, apply to any of our descendants that are different from us, like including humans, right? If that was the whole argument. So the paper accepts it's possible for a good explanation to be more false than a bad one. And as with the previous section of this talk on Dutch books, these criticisms are about the internal inconsistency of explanations, or sets of explanations, or sets of explanations in the mind, right? So it seems to me that all criticism of explanations is like this. So out of the two halves of creative reasoning, conjecture and error correction, for the error correction side, living a rational life is about your ideas bounding upwards as bad explanations are self-eliminated in your mind, thus levering up and levering out your remaining ideas. Thanks for listening.
Oh, are you doing questions?
I guess I have time for 5 minutes. I was actually pretty short.
5 minutes.
5 minutes.
You're good.
I'm wondering, can you say again what you disagree with Deutsch about? I don't remember that.
Oh, sure. So if that ends up with 2 copies of me after I measure a spin-up, spin-down particle, and again, I'm ignoring all the splitting from thermal motion as depends on the lab, right? Where there are actually just many worlds, many different branches of the wave function. So there's 2 of me, and how could it be the case that it's not 50% chance that I end up in one and 50% the other? And some people would say, like, oh, we just have to throw away the branch counting rule. I don't think Deutsch really defends the branch counting rule, but he does basically solve that by saying, well, there aren't 2 copies of you in the end. You have these 2 worlds, but there's like indefinitely many of one of them and definitely many of the other. Anyone else? Yeah.
Sorry, I think I'm just being a bit dense, but I didn't quite follow the relationship between the discussion of objective Bayesianism in the first half and then how exactly this relates to betting in different branches of the multiverse. Yeah.
Sure. So I constructed like a definition of probability, this sort of operational definition, and my talk really didn't defend whether it's the right version of probability or not. just so there's one thing you could do. But in that framework, it's really the internal inconsistencies of agents. And so the set of possible agents that can exist that are internally consistent, that grounds that definition of probability. And my talk is just also pointing out that this happens with bad explanations and comparing the two. So there were slightly two different segments, but with that similarity. Yes, okay, well, thank you.